In this lecture, we would see the generation of computer. So let's discuss about this. We know that necessity is the mother of invention. The saying holds true for computers too. Researchers invented computers because of man's search for fast and accurate calculating devices. The first mechanical adding machine was invented by Blaise Pascal in 1642. Later, in the year 1671, Baron Gottfried Wilhelm von Leibniz of Germany invented the first calculator for multiplications. Keyboard machines originated in the United States around 1880, and we use them even today. In the same period, Hermann Hollerith came up with concept of punch cards that computers used extensively as input medium even in the late 1970s. Business machines and calculators made their appearance in Europe and America toward the end of the 19th century. Charles Babbage, a 19th century professor at Cambridge University, is considered the father of modern digital programmable computer. He had employed a group of clerks for preparing mathematical and statistical tables. Babbage had to spend several hours checking these tables because even utmost care and precautions could, re- could not eliminate human errors. Soon he became dissatisfied and exasperated with this type of monotonous job. As a result, he started thinking about building a machine that could compute tables guaranteed to be error-free. In this process, Babbage designed a difference engine in the year 1822 that could produce reliable tables. In 1842, functions for any mathematical problem at any average speed of 60 addition per minute. Unfortunately, he was unable to produce a working model of this machine because the precision engineering required to manufacture the machine was not available during that period. However, his effort established a number of principles that are fundamental to the design of any digital programmable computer. A major drawback of early automatic calculating machines was that their programs were wired on boards that made it difficult to change programs. In 1940s, Dr. John von Neumann introduced the stored program concept that helped in overcoming hardwired program problems. The basic idea behind this concept is that a sequence of instructions and data can be stored in memory of computer for automatically directing flow of operation. This feature considerably influenced development of modern digital computer because of ease with which different programs can be loaded and executed on a single computer. Due to this feature, we often refer to modern digital computers as stored program digital computers. The first generation 1942 to 1955. The characteristic features of first generation computers are can be pointed out like They were too bulky in size, requiring large rooms for installation. They were the fastest calculating devices of their time. They used thousands of vacuum tubes that emitted a large amount of heat and burnt out frequently. Hence, the rooms areas in which these computers were located had to be properly air conditioned. Each vacuum tube consumed about a half of a watt of power. Since a computer typically used more than 10,000 vacuum tubes, power consumption of these computers was very high. As vacuum tubes used filaments, they had a limited life. Because a computer used thousands of vacuum tubes, these computers were prone to frequent hardware failures. In this computer, thousands of individual components were in this computer, thousands of individual components were assembled manually by hand into electronic circuit. Hence, commercial production of these computers were very difficult and costly. Due to low mean time between failures, these computers required constant maintenance. Since these computers were difficult to program and use, they had limited commercial use. Now the second generation. In second generation started in 1955 and ends in 1964. John Bardeen, William Shockley, and Walter Baratain invented a new electronic switching device called transistor at Bell Laboratories. Transistors soon proved to be a better electronic switching device than vacuum tubes due to their flowing properties. They were more rugged and easier to handle than tubes since they were made of germanium semiconductor materials. They were highly reliable as compared to tubes since they had no parts like a filament that could burn out. They consumed almost one-tenth the power consumed by a tube. They were much smaller than a tube. They were less expensive to produce. They dissipated much less heat as compared to vacuum tube. So these are the properties of transistor, which can be used as a switching device in the second generation computer. In the second generation, it also experienced a change in storage technology. Memory of second generation computer was composed of magnetic cores, and magnetic cores are small rings made of ferrite that can be magnetized in clockwise or anti-clockwise direction. Large random access memory having a storage capacity of few tens of kilobytes had several magnetic cores strung on a mesh of wires. In the year 1957, researchers introduced magnetic tape as a faster and more convenient secondary storage medium. Later, magnetic disk storage was also developed, and magnetic disks and magnetic tape were the main secondary storage media used in second generation computer. Users still used punched card widely for preparing and feeding program and data to a computer. On software front, high-level programming languages like Snowball, Algol, COBOL, Fortran and batch operating system emerged during this second generation. In addition to scientific computation, business and industry users use second generation computers increasingly for commercial data processing applications like payroll, inventory control, marketing, and production planning. Now we can discuss the characteristics of second generation computers. They were more than 10 times faster than the first generation computers. They were smaller than first generation computers and required a smaller space. They were more reliable and less prone to hardware failures than the first generation computers. They consumed less power and dissipated less heat than the first generation. The rooms areas in which the second generation computers were located are still required to be properly air conditioned. They had faster and larger primary and secondary storage as compared to first generation computer. In these computers, thousands of individual transistors had to be assembled manually by hand into electronic circuit, making commercial production of these computers difficult and costly. They were easier to program and use than the first generation computer, hence they had wider commercial use. Now we will see directly the characteristic features of third generation computer. They were more powerful than second generation computers. They were capable of performing about 1 million instructions per second. They were smaller than second generation computers, requiring a smaller space. They consumed less power and dissipated less heat than second generation computers. They were more reliable and less prone to hardware failures than second generation computers, requiring lower maintenance costs. They had faster and larger primary and secondary storage compared to second generation computers. They were general purpose machines suitable for both scientific and commercial applications. Their manufacturers did not require manual assembly of individual components into electronic circuit, resulting in a reduced human labor and cost involved at assembly stage. Hence, commercial production of these systems was easier and cheaper. However, highly sophisticated technology and expensive setup was required for the manufacturers of IC chips because third generation computers have started to use IC chip. A standardization of high-level programming language allowed programs written for one computer to be easily ported to and executed to another computer. Time-sharing operating system allowed interactive uses and simultaneous use of these systems by multiple users. Time-sharing operation system helped in drastically improving the productivity of programs, cutting down the time and cost of program developed by several fold. Again, time-sharing operating system also made online systems feasible, resulting in usage of these systems for new online applications. Unbundling of software from hardware gave users of these systems an opportunity to invest only in software of their need and value. Many competitors of third generation made computers affordable even by smaller companies.